So welcome to another in the webinar series, which we're running for Egeria. We ran a number of them last year, and this is the first of a set of webinars we're going to do around connectors. There's going to be two lots of two. We're going to be doing using an integration type connector, and then we're going to have how to build one, followed by using a repository connector and how to build one. We're also going to have Kubernetes operator webinar this year. So I think it's quite an exciting year for the webinar series. And then followed by that, we're going to continue what we started with. What do you do after you've built a catalog? So we did part one, and we're going to continue with part two. So we're interleaving these topics, so you have a chance to digest each of them. And of course, you can always request other webinar content that you want, or if you want to present to us, that'd be fab as well. So over to you, Mandy.
Okay, thank you very much. So as the title says, this webinar is on using integration connectors, and I'm going to talk a bit about the motivation for this type of connector, and then go through different types of use cases that you can enable through our integration connectors and the server called the integration daemon that supports them. So as usual, we're going to start with our Coco Pharmaceuticals set of use cases. And this particular one is going to center around Callie, who is one of their data scientists. And she's quite senior, and she does a lot of different projects, and she's working for the clinical trials team, looking for new products for the company, but also verifying that patients who are taking part in a clinical trial are healthy and the right outcomes are detected. So she's busy, and she's doing lots of different projects. And so in her work environment, she's constantly creating new copies of data sets, building sandboxes for her work. And when the work is successful, or when it's part of the clinical trial, actually the content of that sandbox needs to be governed. It forms part of the lineage of any downstream analytics that's going on from that sandbox. And so one of her jobs is to catalog the sandbox and to cover its lineage. But often she forgets. Often for her, it's an admin job to add to the catalog. And so we're looking to say, well, how can we help Callie, who's busy, to create the right catalog entry for her sandboxes as she creates them, but also allow for the fact that she might delete them because it's a mistake or whatever. So we need to catalog proactively, but also allow her to control and update that catalog entry. So the way we do this is with something called the integration daemon. And this is, as a daemon, as its name suggests, it sits in the background. It is monitoring Callie's sandboxes, however they're implemented, and is automatically cataloging them. And if you've come to our previous webinars, you'll know that when we catalog, there's certain types of metadata that is easy to catalog. It comes directly from the implementation of the data platform or the data store. And we call that technical metadata. And often this is where it exists. This is what it's called. This is the type of technology it's using. And for some technologies, this is the structure that the data is organized in. So if, for example, Callie was using a database as for her sandboxes, then we would be able to pull that database schema and understand the structures of the individual fields. So that's step one. But the other thing that we can do is use something called a template. And a template describes additional metadata that should be added to the new entry based on another entry. So basically you build a sort of archetypal entry for the sandbox elements. And when we create, so Callie creates sandbox B, then we use that archetype to set up some of the governance definitions. And so that might be the owner, which would be Callie in this case, and the zones. So the zones just control the visibility of the asset. So we might say early on, only Callie can see the sandboxes. Seems reasonable. They're private to her. So even though they're being catalogued, the catalog entry is invisible to everybody else. So she knows that it's only when she chooses to publish that it becomes visible through the large data catalog. So that's basically the role of the integration daemon in this particular sample. So we've got two parts to it. One, it's detecting and cataloging the technical metadata. And two, it's using templating to extend the metadata that's cataloged to allow that very first set of governance metadata to be applied to those assets. And we take that idea and we say, well, it's not just for databases and data sets, but really any part of the digital landscape should be, we should be able to automatically catalog. So that the organization that's running Egeria is maximizing the knowledge that's being captured automatically from systems, tools, APIs, data sets, sort of event processing systems, all different types of tools and processing engines, and even configuration files. So all of these things contain useful and interesting metadata. And so we really want to be able to capture it. The other thing that's important is that it's all very well capturing metadata, but that just takes up disk space. Yes, you can then have a search and help people find things, but really where it's valuable is if we can then push it and use it to configure downstream tools. So not only are we capturing what's new and what's coming in, we're also using the existing metadata to consistently configure downstream systems. So the way to think about the integration daemon is that it's potentially bringing metadata in, pushing it out, and it can actually handle a two-way exchange with another tool that's not using open metadata. So at the top of the page, you'll see asset catalogs, and the integration daemon can match the can actually sort of do a very sophisticated exchange with another asset catalog through its processes. It has no metadata store itself, so it's a governance server, and it sits and communicates with a metadata access server. So that might have its own local store, or it might rely on the cohort to provide the storage. So think of it as the second level governance server sitting connected to a metadata server. So as we bring metadata in through the integration daemon, it's translated into the OpenLineage format and stored in the metadata access server, either locally or through the cohort. So everything that's coming in through the daemon ends up stored in open metadata. So we're effectively making a copy of it, and then when we push it out, we are then also copying, obviously making another copy as we push it into the downstream. So this is a sort of synchronizing, copying, pushing, pulling type thing. Now, there are lots of different types of technology, and they have different types of capability. Some are quite open in that they have open APIs. Some are very, very helpful in that they produce notifications when things change in their environment, and others are pretty closed. They might have blocking APIs to allow polling to their APIs, or, and as I say, they may have ability to register listeners. So we need to be able to cater for a very wide range of technologies. But also we need to make sure that we don't, we have a reasonable amount of code to manage in Egeria. So we need to break this problem down into what's needed for every integration. And that's the function that's supported by the integration daemon. What's special for a particular type of technology in terms of the way we need to interact. And that again that comes down to a very small number of patterns, and that is in the integration daemons framework. And then we need to say, well, what metadata do we need to store for each different type of technology? And so that has to be a certain aspect of the framework. And then finally, there's the specific API for the specific type of technology. Now, if you take those different requirements, you'll find that you'll actually start to see why the integration daemon is designed the way it is. So I'm going to switch to the next chart, and this is looking inside the integration daemon. So the green area is the server itself, and it's responsible. Well, let's start in the middle actually. So in blue there are a set of connectors, different styles of connectors. That's the integration connector. That's the topic that we're talking about. So this is the smallest amount of code required to actually integrate with a particular API. And there may be different styles, and the framework that the connector sits in supports its different styles. So when it's configured, the configuration includes what style it's using, and the connector is then able to support that style. What's going on around it is it sits in an integration service, an OMIS, and that integration service provides a context API that is specialized for the type of technology. And by that, I mean, so a database is a type of technology, a file is a type of technology, a search engine is a type of technology, an ETL engine is a type of technology. And each of those catalogs slightly different types of metadata and is interested in being notified about different types of metadata. So the integration service is providing this specialist metadata interface for a particular type of technology. So that's the next level. Then we have to think about, well, we've got to start and stop the connector. We've got to be able to scale it. And that aspect is handled in the green area by the integration daemon itself. So the daemon handles everything that's consistent about talking to any type of technology, irrespective of its integration style or capability or metadata need. The integration service focuses on the specialist metadata interface that's needed for a particular type of technology, and the connector is responsible for making the specific API calls to query, update, listen for particular types of elements. And if you think about what it's doing, it's sitting in the middle and it's trying to create consistency between what we have stored in open metadata in Egeria and what is stored in the technology that it's connected to. And there's always a priority. So if, for example, we think of a database, the structure of that database, the only technology that owns the definition of that is the database. There's no other technology that can tell the database it's wrong. That's its schema. So basically, if there's any inconsistency between what's in the database and what's in open metadata, it's open metadata that changes. So we would be basically making the connector's job is to make open metadata's definition of that database's schema consistent with the technology. Now, if we were going the other way, if, for example, we were using open metadata to configure a security tool, for example, open metadata is in charge. And so any discrepancy between the two results in an update in the security manager in this example. So there's always what we call a permitted synchronization. And that is basically saying, what is the direction of travel of the metadata? That's maybe the way to think about it. And for some connectors, it's all going outbound. And for some connectors, it's going inbound. And when we're dealing with an external catalog, it's a two-way synchronization. And we're looking at individual elements as to which one is owned on either side. So it's slightly more complex extraction. So one of the things you'll see is that not only are we looking at being able to connect to the third-party technology, but the integration service is using the client of our access services, which is the specialist APIs to the metadata, not only as the REST API for the REST API calls, but also for the topics. Most of them, I don't think we have any that actually use the in topic, although architecturally, this picture is correct. Most of them listen for changes to metadata of a particular type and allow a connector to listen, to also be notified whenever a certain type of event happens, and also provides basically Java access to the REST APIs behind, so that either changes can be made to the metadata or metadata can be retrieved in order to validate that it's consistent with the third party's technologies version. So that's what's going on. You think of it as a piggy in the middle, but generally there's a direction of flow of metadata either from the third party technology into Egeria, and we're trying to keep Egeria consistent, or we're taking metadata from Egeria and we're pushing it to the third party technology, and we're looking for discrepancies there. And we have to think not just of things being created, but also things being changed and most importantly deleted. Because we need to make sure that the consistency is complete. Okay, so that's the design of the integration daemon. Now, I talked about the fact that different types of technology need different types of metadata, excuse me. If you know Egeria, the metadata server has a lot of different types of interfaces called access services, or OMASs, Open Metadata Access Services. And those provide specialist APIs for different types of metadata. So there's one for setting up a governance program, there's one for cataloging data stores, there's one for managing IT infrastructure. And so those specialist APIs make it easier to use the interfaces, because the interfaces are designed for particular types of metadata. And we do the same with the integration daemon in that each of the integration services that provide that context, that specialist metadata interface to the integration connectors, it's paired with an OMAS that's consistent. And it's many to one, basically, that an OMAS will only ever work with, an OMIS, the integration service, will only ever work with one OMAS, but an OMAS may be supporting multiple integration services, OMISs. So this picture sort of shows the types of things, and the reason for knowing that is when you're setting up your integration daemon and you know that, oh, I'm going to use the files integration service and the database integration service and the security manager, the security integration service, the partner the partner OMAS tells you which services, the OMAS services, you need to activate in the metadata access service. Okay, so that's the pairing. So let's look a little bit more into the way that the integration connector is configured. So we talked about the fact that it's talking to a particular type of technology, so it belongs in a particular type of integration service. And so the integration daemon, when it starts up, it gets a list of which integration services to start. And then within that integration service configuration is a list of the connectors, the integration connectors to start. So you've got an array of integration services, and then within that, an array of connectors. And the information that is in describing the connectors explains how that connector needs to interact with the third-party technology, and it determines the threading and the number of times that it's called to perform particular activities. So that's the configuration, and you see that if you look in our admin guide. The implementation, and the next webinar is going to go into this in a lot more detail about what's really going on in all of these calls and how the threading is managed. But actually, all the runtime management of the integration connector is actually handled by the integration daemon. So it has of all the connectors that are running it, it manages one big list. And the role of the integration service is just to provide the context, the right implementation of the context, providing the right type of metadata interface to the connector. So the management, so most of the logic, the intelligence is actually in the integration daemons services. And so if you imagine that the integration daemon is managing all of these connectors, one of the things that's not helpful is if a connector goes and issues a blocking call. And because of that, one of the configuration mechanisms is to say that this connector is going to use blocking calls, and that tells the integration daemon to give that connector its own thread, whereas all the other connectors will run will basically run on the same thread, and they each get a turn to do something, because in general integration connectors aren't running at millisecond, they're polled at millisecond times. They are they might run once a day, once a week, once an hour, that sort of time, and so the integration daemon just manages that capability. Okay, so I've given you just a feeling for the framework and what it's doing. It is possible when you're running the integration daemon to look at the status of all the connectors running. You can refresh them, you can give them new configuration properties while they're running as well. So there's a little bit of dynamic behavior that you can do, but in general, they run as configured as they go through. So that's the integration connectors implementation. So now I'm going to spend the rest of the call taking you through some scenarios to show you the art of the possible once now we have this very generic capability that allows this two-way integration. So let's start with very simple, extracting metadata from different types of technologies. And so we have being the database integrator. So in gray, that's the integration service. So the database integrator, not surprisingly, integrates database servers. So basically you connect to the database server and extract the details about the schemas, tables, columns, etc. The files integrator works on either open file systems, and it can, the connector can monitor changes to the file system, or it might work with a content manager that actually maintains complete ownership of a set of documents and has extra metadata around, sort of classifying and tagging that particular type of particular type of documents that it's managing. Then we also have the ability to connect with an event broker like Kafka and extract the topics, and if it supports schemas, the schemas as well. Or we might connect to an API gateway or an application that has the open API specification enabled, so we can extract the information about its supported REST APIs and bring that in. And all of those integration services, as you can see, are owned by the data, are connecting to the data manager OMIS, which is then able to store it either locally or in another member of the cohort. And in all of these cases, the metadata is coming from the third-party technology into Egeria. So we're always trying to make Egeria accurately reflect the metadata that is stored in these elements. So that's just simple metadata extraction. And of course, that's, as I said, when we show the cohort area, the light blue area, you can mix and match whether things are stored locally or in remote partners, or generally with the way that cohort piece is laid out in our diagrams is more for the aesthetic view or the ability to sort of show different parts of the process. And that's why we separate them out. So as I say, the data manager could be an access point, i.e. it has no local storage, but it pushes everything that comes into the cohort, and another member picks it up and stores it. So that's metadata extraction. Now, let's say we want to do some distribution. So for example, it might be that that an organization has databases replicated around the world. And in order for that data replication to work, they also have to replicate schema changes. And so what we're showing here is that the left-hand side is the original, and this is just gathering information about that database, the sort of lead database server, and any schema changes. We pick up the schema changes that results in notifications across the cohort, and the metadata member of the cohort where the sort of replicated database is located picks up those events, and then they are used to trigger updates to maybe an external copy of the database, so the schema update is applied to that thing, or it might be other types of notifications that indicate, wait a minute, there's been a schema change. Maybe it may, for example, another thing that happens is that ETL jobs that access that database also need updating. So it might be that the notifications are going to the development team, the ops team, to say there's something's changed in this database and we need to take action because something will fail as a result of that change, or maybe that it shouldn't have changed. And this notification mechanism is basically identifying a security breach in the system. So that's all the reasons why it's not just about collecting metadata, it's also acting on changes that are unexpected, or even changes that are completely valid but need follow-on action. So that's distribution. And then we might be getting really sophisticated. And so what's going on here is that so you imagine a new database is coming into the data lake. We are cataloging it dynamically through the original integration daemon. That's causing notifications to flow across the cohort. And then there's another integration daemon listening to that and dynamically configuring a data virtualization engine or data federation engine with views that then map down onto the original database. And this style of using a virtualization engine as a sort of first point of call for users of a data lake, say maybe data scientists, is that virtualization engine may be doing additional security checks. It prevents the need for the data scientists to have the log-on user ID and password of the database server. They just connect to the data virtualization engine. It can do additional logging, metering, all that sort of types of things. So this type of style allows the sort of dynamic management of a data virtualization engine. And as the number of databases, files, and things that need the update to the data virtualization engine increase, of course, it's not cost effective to have a human do that. So this is a mechanism that allows that automatic update. And what you'll actually see is that there is also an integration connector listening to schema changes in the data virtualization engine, and that is then coming back and being configured. So not only are we updating the data virtualization engine, but these new views are also then incorporated into the catalog. And if you're smart with the way you've done your governance zones, the views are then visible to the users, the catalog users, and the original database schemas are in a different zone and are invisible. So when the end users do a catalog search, all they see are the database views, which are the things that they can actually use. And the underlying infrastructure that supports their database queries is invisible to them. So there's synchronization. Now we're going to go on to a two-way piece. So we're going to talk a little bit about working with external catalogs. And I called that an asset manager. So what we have here is a tool that is itself cataloging different types of technology. It might provide governance. It might be looking at, it might belong to a different organization that's using different technologies. It might be a configuration management database, so looking at the IT infrastructure. It might be a data catalog. It might be something that's related to security. So, but it in itself is a fully fledged catalog, and we have a special integration service called the Catalog Integrator that's designed to support this. And why it has a special interface is because the asset manager has its own notion of the identity of the technology that it's cataloging, and that same technology may be cataloged or in Egeria via a different route and a different tool. So we need to be able to think about how we correlate different identities in the different catalogs. We also need to make sure that, because we may have a two-way synchronization going on, some things are owned by the external asset manager, and some things are owned by the open metadata. So that's why that is a slightly more sophisticated sister API. And what's going on is that the integration connector is managing mappings of external identifiers, and there's a specific type of open metadata element called the external identifier that provides the ability to look up something based on the external asset manager's identifier, and then being able to navigate to the open metadata element that has its own unique identifiers from the GUID and the qualified name. And it's clever enough to allow an open metadata element to have multiple external identifiers, even from the same asset manager, because in the external asset manager, it might be 2 elements, and in Egeria, it might be 1. So here we've got an example where a business term, glossary term, in the external catalog is represented by 2 elements, the actual term itself and an example, and in Egeria, it's 1 object. So the external identifiers for each of the 2 elements are linked through the external identifier. And that's then tied back to the asset manager element, and that's the software service, software capability, excuse me. And that's because typically these unique identifiers are only unique within a particular tool. And so we need to allow that GT1 might mean something completely different in a different asset manager. And so that's why these external identifiers are always tied to a specific source inside open metadata. So that's why you see that second level. And if we look at the next picture, we're going the other way, in that Egeria uses multiple elements to represent something that's a couple of elements in the external catalog. And so you see that we only have 2 external identifiers, but actually they are linked to multiple elements in Egeria. So we can look up from either direction, basically. All these links are 2-way. So we could start with an Egeria identifier and find out the identifier in the external system, or the other way around. Okay, so that's catalogs. That's a 2-way. Now, so I'm going to show you some other things. We've talked about these. All of these examples have come off of the website. I've just been picking up pictures from the websites. So some of this should be familiar to you. So what this particular picture is showing our integration daemons, both pulling information from different systems and pushing out to others. And it's around the scenario where an organization has just decided that they're going to use Egeria, and they want to get information about their people into open metadata, so that they can then assign people to different governance roles. They can assign actions to people when we discover there's an invalid piece of data, or so that there's some metadata needed, or a decision approval, etc. So we need to know who people are in order to be able to drive the governance aspect. So what you see under number 1 here are 3 of the company's existing applications that manage data about people. There's the organization information manager, which describes, it's like the HR system. The company directory has everybody's phone numbers and email addresses in it. And the security admin, administration, sec admin is basically where they define, you know, sort of who has access to what. So this is the, I think, the tool that pushes to LDAP normally. And so we have integration connectors that are connecting to these applications and populating open metadata with knowledge about profiles, user identities and roles, departments, team structures, and how that organization is sort of structured so that we can do things like approvals to a manager, that type of scenario. So that's all coming in. And again, it could be stored in the connected metadata access store or somewhere else in the cohort. But as that is stored in through community profile OMIS, there are events that are triggered that cause other actions to happen in different OMISs. And so we might be doing additional analysis used through the engine host, and this will be covered in a later thing, how this engine host works. But basically what it's doing is it's looking at those values and making updates to create additional metadata based on what it's seeing there. So it might have different rules that determine, depending on where somebody is located in the organization, they might get access to a certain security group in LDAP. And then as that's working, again, more events happen, and our security manager OMIS starts sending out messages to say this user identity has been associated with another security group, and that then can result in updates going into LDAP, for example. So here, basically, you're seeing a pull of information from the existing applications of the organization, Egeria then using those values and augmenting it with additional rules and creating new values. And then the result of that work, creating new events for new types of metadata that is then populating and pushing out to LDAP in that example. And this pushing to LDAP dynamically, automatically, however you want to say, becomes increasingly important when organizations have multiple cloud platforms or different deployment environments that have their own user directory. So this creates consistency. It also makes auditing an awful lot easier if the directories are being consistently populated rather than having different administrators manually maintaining them as we go through. So that's another example, a sort of pull and then a push. Another way of doing it is if we need to get a human to do something. Here we're using the integration daemon to push a request to email, to instant messaging, to some tool that is going to wake somebody up to say, by the way, you need to do this piece of work. And maybe it's an email or a message with a clickable link that takes you through to the page that needs an approval and update. The results of that push back into Egeria and the process completes. So this is really, again, pushing out, but to talk to a human rather than to update metadata in another system. And then the final one, I think it's the final one. Yes, I think nope, got two more to do. So this next one is a little bit moving on from the populating LDAP, but we may also want to populate the access control system that uses LDAP, but also adds in rules and extra information. So if you think about when you want to access a particular data store, you have your identity and you have a list of the things that you're allowed to see, and then you ask for a particular resource, and then that resource has a set of properties that determines what's needed to access for a person to access it, and then the two are compared, and then you get a yes/no decision. So this is about populating knowledge about the actual data sources and their requirements. And some access control systems use what we call access control lists, which are basically sort of very simple yes/no mechanisms for determining access. Others work with rules and tags. So, for example, if this is tagged as personally identifiable information, then the following rules apply, or the following access rules permissions are needed. And so we have a classification called the security tags classification that can be used to populate such a access control system, and Apache Ranger is an example of that. So that we can push those tags out to the access control system. They would look up the user in LDAP, compare it to the security tag, apply its own rules, and then give access or not. So being able to, again, automatically configure these types of tools consistently from open metadata has a lot of value. But insisting that somebody goes and types in the security tag for each column in every database as it's catalogued is obviously not, it's not cost effective. We may be able to put the security tags in the template. I talked about the template allowing extra metadata to be attached dynamically when new things are catalogued, but it might be a little bit more nuanced in terms of what those values are, in which case we would use a governance action service. So this is an automatic triggered and running sort of governance service that runs in Egeria's engine hosts to look at all the other settings that are associated with it, whether it's, for a particular column, what type of data, whether it's been classified, whether the database is classified, who owns it, where's it come from, what type of data does it contain, all those sorts of things come together to set up the security tags. And then we attach the tags to the column. That change in metadata then triggers the pushing of the tag out to the security manager. And the beauty of this style is that it's fully auditable. It's very easy to say, is that tag consistent with the way that the metadata is defined, and any changes, of course, can trigger changes in the security tag as well. And so this picture here shows our traditional gathering of information through the integration daemon. Then you see the engine host on the left-hand side that's pulling extra metadata from the discovery service. So it might be looking for credit card numbers and other things that might suggest personally identifiable information. And that's being catalogued along with the original technical metadata. Plus then the governance action service there is looking at all these values and building the tags. The tags catalogued in Egeria, resulting in messages that then push out to the out through to the security manager through the tag synchronization connector, integration connector. So here we're again capturing, augmenting, pushing. Now, the last section is around Lineage, and Lineage again is the most important thing about Lineage is it's useful to collect it, but the most important thing is really we need to be able to work with it, use it, and that's where the value really comes. So when we look at our Lineage management architecture, you see the familiar integration daemon there acting as the capture of metadata, because the more automated, the better. Then we see the engine host augmenting. And then finally, in this particular case, we have a special governance server called the OpenLineage server. And you think of that as a specialist warehouse for Lineage. So it's really around, it's monitoring what's going on in open metadata and extracting what's useful from a business perspective, and keeping a copy of that safe so that we have both historical and current lineage that's optimized for particular types of lineage queries. So here again, you can see the role of the integration daemon and the integration connectors running inside it, in that it gives us the maximum reach to gather the information that we need around what's going on in the digital landscape. But we also take advantage of a new standard called the OpenLineage standard, which is a sister project to Egeria in the LF AI and Data Foundation. And this defines a standard payload and API for publishing lineage from processing engines. So if you think about a Spark engine running a job, it produces a set of events that tells us what when it started, what data it accessed, what results it produced, and when it finished. So we can, through the integration daemon, we can gather that, we can listen for that type of event, we can store it, we can distribute it, and we can take action based on it, because the integration daemon supports OpenLineage natively. So let's look at how that happens. So the OpenLineage standard, as I say, it defines the payload of the event and an API endpoint. So any server can implement that endpoint and be open metadata enabled. And so the Marquez is another LFAI and data project, and it is the what we call the reference implementation of this standard. So it is a place where you can go and sort of say, oh, if I want to implement it, you know, if Marquez understands what I'm sending it, then we're doing the events right. So that's our gold standard effectively. So what we've done with Egeria is, the other thing that the OpenLineage team have done is built something called the proxy backend, and this allows this implements the OpenLineage endpoint and publishes any events out to Kafka, and it's pluggable what it could publish to, but the initial implementation is Kafka. So it means that the proxy backend can be deployed with the runtime engine, because there's a runtime dependency to the endpoint for the engine. Allowing it to be deployed together means they can be run together and managed together and upgraded together and started and stopped together. And then through Kafka, we create an asynchronous integration, so that reduces that runtime dependency between the two pieces. So that gives us the ability to receive receive OpenLineage events through Kafka, and that's a fairly natural ability for any integration connector to be able to receive events from Kafka. So there's our first integration with OpenLineage. We did go further. We also added support for the HTTP endpoint from OpenLineage, and that means that an engine can connect directly to the integration daemon, and Egeria will pick up those events. So when you start sort of putting these Lego pieces together, we can have the integration daemon, as I say, sitting there picking up events, and it can make a number of choices. It can store, an engine can produce a lot of events. Some events are more interesting than others, some jobs are more important than others, some data sets are obviously more significant. And so the Lineage integration connector can filter, it can choose what it's going to save to the file system, what it's going to store as lineage metadata, which would then be distributed to the cohort and to the OpenLineage warehouse that I showed you earlier on. So really it can sit there and act as a decision pointer filter for what happens to the OpenLineage. We also, inside that Lineage integration service, it's possible to have multiple connectors asynchronously integrated through what we call the OpenLineage listener capability. So it's possible to have different types of integration connectors listening for OpenLineage events coming in through the HTTP endpoint, and then sort of distributing to different systems. So number 7, you see API OpenLineage log. That actually could be writing to Marquez or any other system that supports OpenLineage. We have one that writes to the file system, another one that pushes stuff out into the open metadata ecosystem. We also because we're a processing engine, that engine host is running open governance action processes. We ourselves produce OpenLineage events so that other tools that are monitoring Egeria's operation, say Marquez, will receive OpenLineage events when we start and stop our governance action processes. So not only are we a receiver, we're a producer, we also store and we consume through our engine processes. So where are we on time? We're getting pretty close to the end. So as I say, I've gone through the art of the possible, the sorts of use cases that you can support with the integration connector. Our next session is all about writing them. So we'll go into how the threads are managed, how you call different types of APIs, how you listen for different types of metadata. And we'll look at different examples of integration connector implementations. So now we've got a few minutes for questions, if anybody has any.
Yeah, quick question, Mandy.
Yes.
Is there any support for versioning within this? So that, for example, you can roll back to a particular version?
Of metadata, yes.
Of
yes.
Metadata, yes.
Yes, absolutely. That's a standard capability of Egeria.
Right.
It's enabled through, well, you have to have a metadata repository plugged in to your cohort that supports history. So
Right.
every piece of metadata is versioned. We need to do that to be able to distribute in a reliable way. And some metadata stores only store the latest version, in which case you can't roll back. But we have our XTDB one, which will support history and will allow you to restore previous versions.
Okay, cool. Thank you very much.
Any other questions?
Okay. One more, actually.
Yes, of course, yes.
Okay, sorry. There's no web. I mean, there's no user GUI interface to all this at the moment. Is that right?
No, it's a daemon. It runs in the background and is cataloging in the background.
But for example, there's nothing that lets you start or stop it or anything like that.
No, there's a Java client and a REST API to do it.
Right. Okay.
Yeah,
okay.
and in fact, David is on the call. I mean, he's working on the UI for that. Starting and stopping an integration daemon is the same as starting and stopping any server in Egeria. You just start it, you give it the name, and it pulls the configuration document, which is the thing. So yeah, starting and stopping an integration daemon is no different from any other server.
And I guess just for completion, if you're in the Kubernetes world, that might be the operator that will be doing that sort of thing.
That's a good point.
Okay, thank you very much.
Mm-hmm. All right, any more questions? All right, so David, back to you.
Well, thank you. That was really good. I'm still amazed that we've managed to get a framework that does all the basic heavy lifting, and then all you have to do is plug in the sort of specifics. And I think, I don't know what people thought. That often you may have thought that it was just about cataloging, which I think is a lot of people are using for the use cases of these integration connectors, and cataloging all your technology using these integration technologies connectors is obviously a really good starting point. And we've done one recently, which is the Strimsy connector, and we're hoping to get that published into Egeria. So if you have a technology in mind then that you want to integrate, you can see that this framework does all of the heavy lifting for you, and really it's just the sort of mapping into Egeria types and setting in configuration which way you want it to flow the metadata. So if you're interested in any of that, then of course we've got the next webinar is all about how you build your integration connector. And if you've got a particular technology in mind, you could use that to guide you on building the integration connector of your dreams. So, and just another thing to mention is we have the dojo, which is on the 18th of February, which is all about developing connectors, not only integration connectors, but also of the other types as well. So, and that's all geared towards developers. So if you're interested in doing a hands-on day about how you do this, then the 18th of February, it's a Friday, where we're going to be spending a day going through all of this. Mandy's prepared a prolific amount of material for you to go through to be able to, so you can get up to speed with developing your own connectors really quickly. So thank you. And I hope to see you next month if you're interested in hearing about building integration connectors.
Great stuff. Thanks so much, David.
Thank you.
Thank you. Okay, I'll shut down the call now, David.